Hello, this is Miss Morningstar again. Today we are still solving systems using elimination. It's actually the next section in your book, 4.2.4. The last time it was 4.2.3. In the last lesson you learned how to use the elimination method to solve systems. In this method you combine two equations in a way that made one variable disappear. This method is particularly useful for solving systems of equations where neither equation is in y equals mx plus b form, which is slope-intercept form. Do you remember what the setup generally is for elimination? It looks like this. ax plus by equals c. Do you remember what that's called? It's called standard form. So a lot of times we do elimination when both equations are in standard form. Don't forget a system of equations is two or more equations with the same variables. Alright, today, well actually, you know what? I want you to take a minute and hit pause and read this and all the questions. When you're ready, turn it back on. Alright, the next question says, which system of equations below would be easiest to solve using the elimination method? Once you have explained your decision, that means write it down. Use the elimination to solve this system of equations. You do not need to solve the other system. It does say record your steps and check your solution. Definitely show your work, but you don't have to check. So take a minute, hit pause, and I want you to decide which of those two is best solved using elimination. When you're ready, turn it back on. Hopefully you picked this one because they're both in standard form, ax plus by equals c, and these are opposites, so you should have tried to solve a. And I'll show you quick the solution. This one would not be good to solve using elimination because they're not in standard form. Standard form means the x's are lined up, the y's, the equals, and the numbers. They're not even in standard form. So hopefully you tried to solve this. Actually, take a minute, hit pause right now, and try to solve that. Okay, on this one you should have added because these are opposites. If you add, if I borrow $8, pay you back 5, I owe you 3. If you add opposites, you get 0. They are eliminated. That's why the method is called elimination. If I borrow $52, pay you back 37, I owe you 15. Divide by -3, x is 5. Don't forget, you take your 5, you pick one of the two original equations, and it's hard for me to even see. No. You can wait. You fill it back in. I chose the first equation. You know, if you're not good at two-step equation, you need to work on it. I gotta move this up. You guys can't even see what I'm doing, I bet. But hopefully I did not make a mistake. I did work this out. That's what I got before. So the solution to this system is 5, -3. That means if I were to graph this line and this line, that would be the point of intersection, because this is the only ordered pair that makes this equation true and that equation true. So I'm not asking you to check right now, but if you did, it says to check there. You would just fill them in to see if they. Alright, this is problem 67, actually from your book. What I would like for you to do is hit pause and try A. When you're done, turn it back on. Alright, when you try to combine these equations, if you try to add them, 2x plus 3x is 5x. If I borrow $2, pay you back 1, I owe you 1, and 10 plus 1 is 11. Was either one of the variables eliminated? It was not. You still have your x and you still have your y. Whereas back here, when you add them, the y's were eliminated. Okay? Now, what I want you to do, hit pause again, and I want you to try B. I want you to read it and answer it and write down, figure out if they're the same line, and justify and all that. Hit go, hit play, or turn this back on when you're ready. So what do you think? Do you think they are the same line? In other words, is this the same as this? Do they have the same solutions? I mean, there's one way to check quick. You know, if I pick a 0 for x, 2 times 0 is 0, 0 plus 10 is 10. If I pick a 1, 2 times 1 is 2. 2 plus what number gives you 10? I put a 2 in, 2 times 2 is 4, 4 plus 6. Okay, that's the table for this graph. Let's do the same for this graph. If I put a 0 in for x, 2 times what number gives me 20? 10. If I put a 1 in, 4 times 1 is 4. 4 plus what number gives you 20? 16. And I realize you guys probably can't do this in your head. If I put a 2 in, I'll get an 8. 8 plus 12 gives me 20, so 2 times. I mean, do they have the same solutions? They do. And you can keep doing it. So if they all have the same solutions, so yes, they have the same solutions. Look at the graphs. Are their graphs the same? Well, yes. I mean, if I plot those and plot those, it would be the same line. So yes, the graphs would be the same. And you need to justify your conclusion. All right, C. Since you can rewrite 2x plus y equals 10 as 4x plus 2y equals 20, perhaps this equivalent form of the original equation can help solve this system. Now, can we combine, if these are equivalent, instead of using this one, I'm going to use this one, it's right here, and these is a variable eliminated. So the question is, if I use these two now, can I add or subtract to eliminate a variable? Well, these are opposites, right? So yes, you can. If you add 4x plus 3, let me move this up. 4x plus 3x is 7x. Aren't these opposites? 20 plus 1 is 21. So x is 3. It says, is the variable eliminated? Yes. If so, solve the system for x and y. Well, there's x. Do you remember how to get y? You pick one of the original problems. I'm going to pick that one. Although you actually could use this one too. 2 times 3 plus y equals 10. 6 plus 4 gives me. So your solution to the system is 3. So the point is, these two are equivalent. So you can multiply an equation by a number, and they're still equivalent, and then just use that to do elimination. Okay, I want you to answer D as best you can right now. I want you to hit pause right now, and I want you to answer D as best you can. And then when you're ready, turn this back on. All right, now, for each system below, determine, is this system a good candidate for the elimination method? Why or why not? So yes, I want you to answer that. What is the best way to get one equation with one variable? Carry out your plan and solve the system for both variables. Okay, and then is your solution correct? Verify by substituting your solution into both the original equation. Okay, take a minute and think about A. Actually, hit pause, and then when you're ready, turn this back on. Is that, can you solve that using elimination? Hopefully you figured out these numbers are the same. You could actually subtract this equation, and you could eliminate the n. Okay. So you're going to solve that for homework after we're finished here. You're going to wait and do that. Okay, what about B? Can you solve that using elimination? Hit pause, think about it, turn this back on when you're ready. Alright, hopefully you figured out if you rearrange this equation, it would be a good candidate for elimination. If you put the 4a here and the plus b here, you could just add and eliminate the b. That is actually going to be your homework for tonight, is to do A and B, all of these parts. All right, now C, is this system a good candidate for elimination? Hit pause, think about it, turn it back on when you're ready. Is it a good system? Could I add them right now? Okay, don't write this down, but if I added 7x plus 3x is 10x, 4 a plus a negative is a plus 2y, 17 minus 15 is 2. Did we eliminate a variable? No. So you can't add. Could we subtract right away? If you subtract the whole entire equation, 7 minus 3 is 4. Subtracting a negative is the same as adding, so 4 plus 2 is 6. Subtracting a negative is the same as adding, you get, I don't even know what that is, 32. Did you eliminate a variable? No. So, what could you do, what did we just work on, is, could I multiply either one of these equations by a number to eliminate a variable? What would happen if I multiplied this equation by 2? 2 times 3 is 6x. 2 times 2 is 4y. If I borrow $15, 2 times I've borrowed $30. Now, aren't these opposites right here? So can't I add and eliminate the y? Now, the reason I did that is because I knew if I could make these two numbers the same, then I could use elimination. So I'm like, well, that's a 4. I could make this a 4 just by multiplying the whole equation by 2. What I would like for you to do for the rest of your homework is go back and reread these bullets. We talked about how to do this one, and I got you started on this one. I would like for you to make a great effort on all of these problems. Then, the other thing on your paper is just write down any questions that you have. Please make an effort to be trying to learn this. It's really important for you to be trying. Like I said, I think this is really neat, but you've got to do it. And last thing I want to leave you with, any ideas what my favorite superhero is? I'll give you as multiple choice. A, Superman. B, Batman. C, Wonder Woman. Or D, Green Lantern. If you don't already know the answer, we'll talk about it the next time I see you.